Right now, the space you occupy is betraying you. The atoms in your body, the air in your lungs, the floor beneath your feet. All of it is held together by laws. Rules written into the fabric of reality itself. Cause precedes effect. Nothing travels faster than light. Distance is absolute. You trust these rules because they have never failed you. But there is a structure in the mathematics of spacetime that reveals something horrifying. These rules can be broken. Not bent, not circumvented, broken, cleanly, completely, permanently. Physicists call them wormholes. Einstein-Rosen bridges. Traversable throats connecting two distant regions of spacetime through a tunnel that should not exist. They are shortcuts through the universe that violate everything you know about distance, causality, and time itself. And here is what will keep you awake tonight. The mathematics that predict them is the same mathematics that accurately describes black holes, gravitational waves, and the expanding universe. The math works. It has always worked. Which means wormholes are not science fiction. They are solutions to Einstein's field equations, real structures permitted by general relativity. The universe allows them to exist. And if they exist, everything you understand about physics, about separation, about the impossibility of faster-than-light travel, becomes a lie the cosmos has been telling you since birth. The year is 1935. Albert Einstein is 56 years old and living in Princeton, New Jersey. He has already shattered Newtonian physics. He has already revealed that time is not absolute, that mass warps space-time, that gravity is geometry. He has already won the Nobel Prize. But something is bothering him. A mathematical ghost that keeps appearing in his equations. A solution that refuses to go away. Einstein is working with his assistant, Nathan Rosen. Together, they are analyzing the field equations of general relativity. These equations describe how mass and energy curve the fabric of spacetime. They have already predicted phenomena that were later confirmed: the bending of starlight around the sun, the precession of Mercury's orbit. The equations work. They describe reality with terrifying precision. But now, buried in the mathematics, Einstein and Rosen find something else. Something that should not be there. They find a bridge. Not a physical bridge made of matter. A topological bridge. A tunnel connecting two separate regions of space-time through a throat that exists outside normal three-dimensional space. The equations allow it. More than that, the equations predict it. If you solve Einstein's field equations for a specific configuration of mass and energy, you do not get a simple point mass. You get a tunnel. A shortcut. A violation of distance itself. Einstein and Rosen published their findings in a paper titled "The Particle Problem in the General Theory of Relativity." They describe these bridges as structures that could theoretically connect distant points in space, or even different universes entirely. They do not call them wormholes. That term will not be coined until 1957 by physicist John Wheeler. But the mathematics is clear. These bridges are not optional features of spacetime. They are mandatory solutions to the equations that govern reality. And Einstein hates them. He spends the rest of his life trying to prove they cannot exist. He searches for a mathematical reason to exclude them, a boundary condition that would make them impossible. He never finds one. The bridges remain, stubborn, permanent, written into the architecture of the universe. Here is why this matters. General relativity is not a guess. It is not a philosophical framework. It is a mathematical description of how gravity works, tested and confirmed by thousands of experiments over more than a century. When the equations predict something, that something tends to exist. They predicted black holes decades before we observed them. They predicted gravitational waves a century before LIGO detected them. They predicted the expansion of the universe before Edwin Hubble measured it. The equations do not lie. And they predict wormholes? But what is a wormhole actually? Not in the abstract sense. Not as a plot device in a science fiction movie. What is the physical structure that Einstein's mathematics describes? To understand this, you need to understand what space-time really is. Not space and time as separate things. Space-time. A four-dimensional manifold where three dimensions are spatial and one dimension is temporal. You exist not as a point in space, but as a line through space-time. Every moment of your life is a coordinate in this manifold. Right now, you are not sitting in a chair. You are tracing a path through a four-dimensional structure, moving forward through time at exactly 1 second per second. Space-time is not empty. It is not a void. It is a fabric, a geometry. And like all geometries, it can be curved. Mass causes this curvature. The Earth curves space-time around it, creating what you experience as gravity. The Sun curves space-time more dramatically. A black hole curves it so severely that the geometry collapses into a singularity, a point where the curvature becomes infinite. But curvature allows for something else, something strange. If you curve a two-dimensional surface enough, you can create a topology where two distant points are connected by a shortcut. Imagine a flat sheet of paper. The distance between two dots on opposite sides is fixed. But if you fold the paper, bringing those dots close together, and then punch a hole through both layers, you have created a tunnel, a shortcut through the third dimension that did not exist when the paper was flat. Space-time can do this, not metaphorically, literally. If the curvature is extreme enough, if the geometry is configured in a specific way, the fabric can fold back on itself. Two regions of space-time, separated by billions of light years, can be connected by a throat that is only a few meters long. You could step into the mouth of the wormhole on Earth and emerge on the other side of the galaxy 1 second later. Not because you traveled faster than light. Because you did not travel through normal space at all. You took a shortcut through a higher dimension. The mathematics allows this, and the mathematics has never been wrong. But there is a problem. A catastrophic universe-breaking problem that reveals just how hostile reality is to anything that tries to cheat. Wormholes, as Einstein and Rosen described them, are unstable. Violently unstable. They collapse. The throat pinches shut in a fraction of a nanosecond, faster than light could cross it. If you tried to enter one, you would be crushed into oblivion before you made it halfway through. The geometry that allows the wormhole to exist is the same geometry that guarantees its destruction. Here is why. A wormhole is held open by the curvature of space-time. But curvature requires energy. Specifically, it requires negative energy, not less energy than expected. Negative energy, energy with a value less than 0. Energy that pulls instead of pushes, that repels gravity instead of attracting it. This is not ordinary matter. Ordinary matter has positive energy. Even antimatter has positive energy. Negative energy is something else. Something that, according to quantum field theory, should not exist in large quantities. But quantum mechanics offers a glimmer of hope, and that glimmer is called the Casimir effect. In 1948, Dutch physicist Hendrik Casimir predicted something bizarre. If you place two uncharged metal plates very close together in a vacuum, they will attract each other. Not because of magnetism, not because of static electricity, because of nothing, literally. The vacuum between the plates contains less energy than the vacuum outside the plates. This creates a pressure difference. The plates are pushed together by the quantum vacuum itself. This was confirmed experimentally in 1997. The Casimir effect is real, and it proves that negative energy exists, at least on microscopic scales. The vacuum between two plates has less energy than empty space. It is a region of space-time with negative energy density. Could this be used to stabilize a wormhole? Could you line the throat of an Einstein-Rosen bridge with Casimir plates, creating a region of negative energy that holds the tunnel open? The answer is yes, mathematically. In 1988, physicist Kip Thorne and his colleagues at Caltech published a paper titled Wormholes, Time Machines, and the Weak Energy Condition. They demonstrated that a wormhole could theoretically be held open if you could generate enough negative energy. Not a little bit, an enormous amount. Enough to counteract the crushing gravitational forces trying to collapse the throat. How much negative energy? Thorne's calculations suggest you would need the equivalent of the mass energy of Jupiter. But negative. An entire planet's worth of energy reversed. Sucking instead of radiating. This is not something you can generate with a battery. This is not something you can create in a laboratory. This is engineering on a scale that requires manipulating the quantum vacuum across astronomical distances. But the math works. A sufficiently advanced civilization, one that has mastered quantum field theory and gravitational engineering, could theoretically construct a traversable wormhole. Not might be able to, could. The physics allows it. And if they could, they would not just break the laws of physics, they would shatter them. Because a wormhole is not just a shortcut through space, it is a shortcut through time. This is where the nightmare begins. In special relativity, space and time are linked. Events that are simultaneous in one reference frame are not simultaneous in another. If you are moving relative to me, your now is different from my now. This is not a perceptual trick. This is a fundamental property of space-time. Time is relative. A wormhole exploits this. Imagine you have a wormhole with two mouths, one on Earth, one orbiting Alpha Centauri, 4 light-years away. If both mouths are stationary relative to each other, the wormhole is simply a spatial shortcut. You step through on Earth, you emerge at Alpha Centauri. Travel time, 1 second. But what if you move one of the mouths? In 1991, physicist Michael Morris and Kip Thorne published a follow-up paper exploring this scenario. If you take one mouth of the wormhole and accelerate it to near light speed, something horrifying happens. Time dilation kicks in. Time flows slower for the moving mouth than for the stationary mouth. This is not theory, this is confirmed. Atomic clocks on fast-moving jets tick slower than clocks on the ground. GPS satellites have to correct for this effect constantly, or your navigation would be off by miles. If you accelerate one mouth of the wormhole to 99% of the speed of light, and then bring it back to Earth, decades will have passed on Earth, but only months will have passed for the moving mouth. The two mouths are now connected across time as well as space. You could step into the Earth mouth in the year 2050 and emerge from the Alpha Centauri mouth in the year 2025. You would have traveled backward in time by 25 years. Not in some vague metaphorical sense, actually backward in time. This creates paradoxes, causality-violating paradoxes, the famous grandfather paradox. If you travel back in time and prevent your own birth, what happens? Do you disappear? Does the universe split into parallel timelines? Does some cosmic safeguard prevent you from altering the past? Physics does not have an answer. General relativity allows closed time-like curves pass through space-time that loop back on themselves, allowing an object to return to an earlier point in its own history. The equations permit this. But causality, the principle that effects follow causes, is one of the foundations of physics. If wormholes allow time travel, causality becomes optional. Stephen Hawking, disturbed by this, proposed the quote, chronology protection conjecture in 1992. He suggested that the laws of physics might conspire to prevent time travel, even if the mathematics allows it. Perhaps quantum effects destroy any wormhole that attempts to become a time machine. Perhaps the universe has built-in safeguards that preserve causality. But this is a conjecture, not a proof, not a law, a hope. A desperate wish that the universe is not as broken as the equations suggest. And the evidence is not comforting, because in 1991, physicists discovered something that suggests the universe might not protect causality at all. They discovered that quantum mechanics, the physics of the very small, might actively support time travel through wormholes. The discovery came from studying what happens to quantum fields near the mouth of a wormhole. When you bring a wormhole mouth back to Earth after accelerating it to near light speed, you create a time machine. But you also create a feedback loop. Light, electromagnetic radiation, gravitational waves, anything traveling through the wormhole can loop back through time. A single photon could enter the future mouth, travel back in time, and emerge from the past mouth before it entered. It could meet itself. This creates what physicists call a runaway instability. The photon enters the wormhole. It travels back in time. It emerges in the past. Now there are two photons, the original and its time-traveled copy. Both enter the wormhole. Both travel back. Now there are 4. Then 8. Then 16. The number doubles with every loop. Within microseconds, an infinite number of photons are circulating through the wormhole, each one adding energy to the system. This should destroy the wormhole. The accumulated energy should collapse the throat, pinching it shut, preventing the time machine from ever forming. This would be the universe's safeguard. Chronology protection through quantum feedback. But the calculations do not support this. In 2003, physicists Sungwon Kim and Kip Thorne performed detailed simulations of what happens to quantum fields in a wormhole time machine. They found that the runaway instability does not necessarily destroy the wormhole. Under certain conditions, the quantum vacuum itself might provide enough negative energy to counteract the positive energy from the feedback loop. The wormhole could stabilize. The time machine could survive. The universe, it seems, does not care about paradoxes. It does not care about causality. It allows structures to exist that violate the most basic assumptions of cause and effect. And if the mathematics is correct, if the simulations are accurate, then wormholes are not just theoretical curiosities. They are weapons, tools, mechanisms for ripping apart the timeline itself. But before we explore the weaponization of space-time, we need to understand what a wormhole actually looks like, not in a diagram, not as an abstract mathematical object. What would you see if you approached one? This question was answered in stunning detail by the visual effects team working on the 2014 film Interstellar. Director Christopher Nolan hired Kip Thorne as a scientific consultant. Thorne provided the equations. The VFX team, led by Double Negative Studios, used those equations to generate the first scientifically accurate visualization of a wormhole ever created. What they discovered shocked them. A wormhole does not look like a tunnel. It does not look like a swirling vortex. It looks like a sphere. A perfectly black sphere hanging in space, distorting the light from the stars behind it. But unlike a black hole which bends light inward toward the event horizon, a wormhole bends light through the throat to the other side. If you look at a wormhole, you see two images superimposed. The distorted space around the wormhole mouth and the distorted space on the other side of the wormhole, visible through the throat. You are seeing two regions of the universe simultaneously, one in front of you, one billions of light years away. both compressed into a single spherical surface. As you approach the wormhole, the image changes. The stars around you begin to stretch and warp, their light bent by the intense curvature of spacetime near the mouth. The image visible through the throat grows larger, filling more of your field of view. You are seeing the destination grow closer, even though you have not entered yet. And then you cross the threshold. The transition is not dramatic. There is no flash of light, no sensation of acceleration. You simply pass from one region of space-time to another. The throat of the wormhole is a region of space where the curvature is extreme but smooth. If the wormhole is properly constructed, if the negative energy is distributed correctly, you would feel nothing. No tidal forces, no crushing gravity, just a smooth transition from one side to the other. And then you emerge. Instantly. One step into the mouth on Earth. One step out of the mouth in another galaxy. The journey that should have taken millions of years at light speed took you 1 second. You did not violate the speed of light. You did not travel through normal space. You used a shortcut built into the geometry of the universe itself. But here is the nightmare that should keep every physicist awake at night. If you can build a wormhole, you can weaponize it. And the weapon is not a bomb. It is causality itself. Imagine a civilization that has mastered wormhole construction. They build 2 mouths. One remains stationary. One is accelerated to near light speed and brought back. The stationary mouth is now connected to a point in the moving mouth's past. You have a time machine. But you also have something worse. You have a causality bomb. Send an object through the wormhole into the past. Have that object do something that prevents the wormhole from ever being built. A paradox. The wormhole exists because it was built, but it was never built because something from the future prevented it. Does the wormhole vanish? Does the object vanish? Does the universe split into 2 timelines, one where the wormhole exists and one where it does not? No one knows. The equations cannot answer this. General relativity allows the paradox. Quantum mechanics offers no clear resolution. The universe has no instruction manual for handling contradictions in causality. But there is a darker possibility, a resolution that requires no new physics, no parallel universes, no cosmic sensors. The Novikov self-consistency principle, proposed by Russian physicist Igor Novikov in 1983. Novikov's idea is simple and terrifying. If time travel is possible, then only self-consistent timelines can exist. The universe does not split. Paradoxes do not destroy reality. They simply cannot happen. If you travel back in time to kill your grandfather, you will fail. Not because the universe stops you, because the timeline is self-consistent. You exist, therefore your grandfather survived. Any attempt to create a paradox will fail by coincidence, by accident, by the gun jamming at the critical moment. Free will becomes an illusion. Every action you take, every decision you make while traveling through time has already happened. You are not changing the past, you are fulfilling it. The universe is a fixed 4-dimensional structure, and your path through it is predetermined. This is not philosophy, this is physics. If wormholes allow time travel, and if paradoxes cannot occur, then the Novikov principle is the only resolution that preserves consistency. And it means you are not in control. You have never been in control. You are a puppet, acting out a script written into the geometry of space-time itself. But even this assumes wormholes can be stabilized. And the requirements for that are so extreme, so impossible, that they border on cosmic horror. You need negative energy. Not a little, a Jupiter's worth. Negative. The Casimir effect proves negative energy exists, but the amount generated between 2 plates in a laboratory is microscopic. To scale this up to wormhole stabilization, you would need to create a Casimir vacuum across astronomical distances. You would need plates the size of planets, positioned micrometers apart. The engineering precision required is beyond absurd. But let us assume you solve this. You have your negative energy. You have stabilized the throat. Now you need to create the wormhole in the first place. Where do wormholes come from? Do they form naturally? Can they be manufactured? The answer is, we do not know. But there are theories. One possibility is that wormholes formed in the first moments after the Big Bang. In the first 10 to the power of negative 43 seconds, the universe was in a state of quantum chaos. Space-time itself was foaming, fluctuating wildly at scales smaller than the Planck length, 10 to the power of negative 35 meters. At this scale, quantum mechanics and gravity merge. The smooth geometry of general relativity breaks down. Space-time becomes grainy, discrete, filled with microscopic wormholes connecting random points in the nascent universe. Most of these quantum wormholes collapsed instantly, but some, theorists suggest, might have been inflated by the exponential expansion of space during the inflationary epoch. A wormhole the size of a Planck length could have been stretched to astronomical scales in a fraction of a second. These primordial wormholes, if they exist, would be scattered throughout the universe, hidden, invisible, connecting distant regions of space through throats that formed before the first atoms existed. We have no way to detect them. They emit no light. They produce no radiation. They are topological features of space-time itself. Unless you stumble directly into one, you would never know it was there. But there is another possibility. A darker possibility. Wormholes might form naturally near black holes. In 1963, New Zealand mathematician Roy Kerr discovered a solution to Einstein's field equations that described a rotating black hole. Unlike the static black holes described by Carl Schwarzschild in 1916, Kerr black holes spin. And this spin changes everything. A static black hole has a single event horizon, a spherical boundary where the escape velocity equals the speed of light. Once you cross it, you can never escape. You fall toward the singularity at the center, a point of infinite density where space-time curvature becomes infinite and physics breaks down. But a Kerr black hole has two horizons, an outer event horizon and an inner Cauchy horizon. Between them is a region called the ergosphere, where space-time itself is dragged around by the black hole's rotation. And inside the Cauchy horizon, near the singularity, the mathematics predicts something impossible, a ring singularity. Not a point, a ring. A circle of infinite density with a hole in the middle. And if you approach the ring from the correct angle, you do not hit the singularity, you pass through it, through the hole, into another region of space-time. The equations suggest this other region could be a different universe, or a different part of our universe connected by a wormhole that threads through the black hole's interior. The ring singularity is not a dead end. It is a doorway. This is not speculation. This is what the Kerr metric predicts. A rotating black hole might contain a traversable wormhole at its core. But there is a problem. The Cauchy horizon is unstable. Quantum effects, specifically Hawking radiation, might destroy the horizon, filling the interior of the black hole with a firewall of high-energy particles. Anyone attempting to traverse the wormhole would be incinerated before reaching the ring. Stephen Hawking discovered this in 1974. Black holes are not entirely black. They emit radiation due to quantum fluctuations near the event horizon. Virtual particle pairs pop into existence at the edge of the horizon. One particle falls in, one escapes. The escaping particle carries energy away from the black hole, Over unimaginable spans of time, the black hole evaporates. This creates a paradox. If the black hole evaporates completely, what happens to the information about the matter that fell in? Quantum mechanics states that information cannot be destroyed. But if the black hole evaporates into Hawking radiation, which is random and thermal, the information is lost. This is the black hole information paradox, and it connects directly to wormholes. In 2012, physicists Juan Maldacena and Leonard Susskind proposed a solution. They suggested that entangled particles, quantum particles whose states are linked across any distance, might be connected by microscopic wormholes. The entanglement is not some spooky action at a distance. It is a physical connection through spacetime, a quantum wormhole called an Einstein-Rosen bridge at the Planck scale. This idea, known as ER equals EPR, suggests that every entangled pair of particles in the universe is connected by a tiny wormhole. You are made of entangled particles. Your body contains trillions of microscopic wormholes connecting you to the rest of the universe. You are not a separate object. You are woven into the fabric of space-time through quantum threads too small to see. And if this is true, then wormholes are not rare. They are everywhere. They are the fundamental structure of reality itself. But these quantum wormholes, these ER equals EPR bridges, are not traversable. They are too small. The throat diameter is measured in Planck lengths, 10 to the power of -35 meters. To put this in perspective, the ratio between a Planck length and a single atom is the same as the ratio between a single atom and the entire observable universe. You could not fit a particle through these wormholes, let alone a human body. They exist only at the quantum foam level, where space-time itself is turbulent and probabilistic, unless you could enlarge them. In 2005, physicist Matt Visser published a paper exploring this exact question. Could a microscopic wormhole be expanded to macroscopic size? The answer depends on how much negative energy you can pump into the throat. Negative energy creates negative pressure, which acts like anti-gravity, pushing the walls of the wormhole apart instead of pulling them together. Visser's calculations show that enlarging a Planck-scale wormhole to human traversable size would require feeding it approximately 10 to the power of 60 joules of negative energy. This is equivalent to the total energy output of 1 billion suns over their entire lifetimes. But negative, reversed, sucking energy out of the vacuum instead of radiating it into space. This is not a challenge of engineering. This is a challenge of rewriting the fundamental constants of physics. You would need to manipulate the quantum vacuum at scales and energies that exceed anything achievable with known technology by factors of trillions. But the mathematics allows it. And in physics, what is not forbidden is mandatory. If the equations permit something, given enough time and enough energy, nature will find a way to produce it. Somewhere in the universe, under conditions we cannot yet imagine, these structures might form naturally, and if they do, they would be invisible. A wormhole produces no light. It emits no radiation. It is a topological defect in space-time, a shortcut that has no electromagnetic signature. The only way to detect one is through its gravitational effects. As light passes near a wormhole mouth, it bends. The wormhole acts as a gravitational lens, distorting the images of objects behind it. But this distortion is subtle. Unless the wormhole is massive, unless it contains the equivalent mass energy of a star or more, the lensing effect would be nearly impossible to distinguish from the gravitational lensing caused by ordinary matter. A wormhole could be floating in our solar system right now, and we would have no way to know. This possibility has not escaped the attention of astronomers. In 2017, a team of researchers led by Kazamo Bambi at Fudan University in China published a paper proposing a method to detect wormholes through microlensing surveys. When a massive object passes between Earth and a distant star, the star's light is briefly magnified by the object's gravity. This is called gravitational microlensing, and it has been used to detect exoplanets, black holes, and other invisible objects. But a wormhole would produce a unique lensing signature. Unlike a black hole, which has a single photon sphere where light orbits the event horizon, a wormhole has two, one at each mouth. If a star passes directly behind a wormhole, its light would be lensed by both mouths simultaneously, creating a double-peaked brightness curve that would be unmistakable. No such signature has been detected yet. But absence of evidence is not evidence of absence. The galaxy contains approximately 400 billion stars. The number of microlensing events surveyed so far is in the tens of thousands. If wormholes are rare, if only one exists for every billion stars, we would not expect to have seen one yet. The survey is incomplete. The universe is not required to reveal its secrets on our timescale. And there is another reason we might not see wormholes. They might not stay in one place. In 1994, physicist David Hochberg proposed that wormholes, even if stable, might be mobile. They are topological features of space-time, but they are not anchored to any particular location. They could drift through the galaxy like icebergs in an ocean, carried by gravitational currents we do not yet understand. A wormhole passing through the solar system might spend only decades in our neighborhood before drifting away, carried by the tidal forces of nearby stars. This introduces a terrifying possibility. A wormhole could appear in your neighborhood without warning. One day, the fabric of space near Earth could spontaneously develop a shortcut to another part of the galaxy. You would not see it coming. There would be no alarm, no way to prepare. The wormhole would simply be there, a spherical distortion in the star field, connecting our solar system to a region of space millions of light years away. And if that wormhole happened to connect us to a region near a supernova, or a gamma-ray burst, or the accretion disk of a black hole, the radiation pouring through the throat would sterilize the Earth in seconds. This is not idle speculation. Gamma-ray bursts are the most energetic explosions in the universe since the Big Bang. They occur when massive stars collapse into black holes, or when two neutron stars collide. For a few seconds, a gamma-ray burst outshines the entire galaxy. The energy released in that brief flash is equivalent to the sun's total output over its entire 10 billion-year lifetime. If a gamma-ray burst occurred within 10,000 light-years of Earth, pointed directly at us, the radiation would destroy the ozone layer, trigger mass extinctions, and possibly sterilize the surface of the planet. We would have no warning. Gamma-ray bursts travel at the speed of light. The radiation arrives at the same time as the optical signal. By the time you see it, you are already dead. Now imagine a wormhole connecting Earth to a point in space 1 light-year away from a gamma-ray burst. The burst happens. The radiation travels through normal space for 1 year, but it also travels through the wormhole instantly. The radiation that should take a year to reach the wormhole mouth arrives on Earth 1 year early. You are killed by light from the future. Causality is not just bent, it is shattered. But perhaps the most disturbing implication of wormhole physics is not what they allow. It is what they reveal about the nature of space-time itself. Because if wormholes can exist, if shortcuts through space and time are possible, then distance is not fundamental. Separation is an illusion. The universe is not a vast empty void with galaxies scattered across billions of light-years. It is a densely connected network of potential shortcuts, a web of topological links that could, under the right conditions, bring any 2 points into immediate contact. You think the Andromeda galaxy is 2.5 million light-years away, but if a wormhole connects Earth to Andromeda, the real distance is whatever the length of the wormhole throat happens to be. 1 meter. 1 kilometer. The 2.5 million light-years is just the distance through normal space, the long way around the path light takes because it cannot access the shortcut. This suggests that distance itself is not a property of the universe. It is a limitation of our perception. We measure distance by counting how long it takes light to travel between 2 points. But light is forced to travel through normal space. It cannot take shortcuts. We are like ants crawling on the surface of a piece of paper, measuring distance by how far we have to walk, completely unaware that the paper is folded and the two edges are touching. The universe might be far smaller than we think. The observable universe, 93 billion light-years across, might be riddled with wormholes that collapse that distance down to nothing. Every galaxy might be connected to every other galaxy through a hidden network of throats, making the cosmos not a sparse collection of distant islands, but a tightly woven mesh, where here and there are meaningless distinctions. And if this is true, then we are not alone. We cannot be. Because if wormholes exist, travel between galaxies is not a matter of enduring millions of years in a generation ship. It is a matter of finding the right shortcut. An advanced civilization would not need faster-than-light travel. They would need wormhole engineering, and once they had that, the galaxy would be theirs in a matter of centuries. This brings us back to the Fermi paradox. If intelligent life is common in the universe, if advanced civilizations arise on even a tiny fraction of habitable planets, then where is everyone? Why have we not been visited? Why is the night sky silent? One answer is that interstellar travel is too difficult. The distances are too vast. Even traveling at 99% of light speed, crossing the galaxy would take over 100,000 years. No civilization could endure that. The motivation would evaporate. The mission would be forgotten. The ship would drift forever, a tomb in the void. But wormholes change this calculation entirely. If shortcuts exist, if they can be found or created, then the galaxy becomes traversable. The silence becomes harder to explain. If wormholes are real, the absence of alien visitors is not evidence that life is rare. It is evidence that something is preventing civilizations from using wormholes. Or something is destroying civilizations that try. There is a theory, a dark theory, proposed by physicist Paul Davies in 2011. He calls it the, quote, wormhole catastrophe hypothesis. The idea is simple. If a civilization develops the technology to create or stabilize a wormhole, they will test it. They will send probes through. They will attempt to traverse it themselves. And if the wormhole is connected to a hostile environment, the result is immediate extinction. The probe emerges in the core of a star, or the ergosphere of a black hole, or the path of a gamma-ray burst. The probe is destroyed. But the wormhole remains open, and now the star's interior, or the black hole's radiation, or the burst's energy, pours through the throat into the civilization's home system. The wormhole becomes a conduit for annihilation. The civilization is destroyed by their own experiment, and the wormhole, now destabilized by the influx of matter and energy, collapses, erasing all evidence of what happened. This would explain the silence. Civilizations arise. They develop technology. They discover wormholes. They attempt to use them. And they die. The galaxy is not empty. It is a graveyard of species that tried to cheat the speed of light and paid the ultimate price. But this assumes wormholes must be created. What if they already exist? In 2013, astrophysicist Pavan Kumar Alluri and colleagues published a paper suggesting that dark matter, the invisible substance that makes up 85% of the universe's matter, might not be matter at all. It might be wormholes. Microscopic wormholes. Too small to traverse, but large enough to exert gravitational influence. The evidence for dark matter is overwhelming. Galaxies rotate too fast. The outer stars should be flung into space by centrifugal force, but they are not. Something is holding them in place. Something with mass. Something invisible. We call it dark matter, but we have never detected a dark matter particle. Every experiment designed to find it has failed. What if we have been looking for the wrong thing? What if the extra gravity is not coming from particles but from space-time itself? A network of wormholes threading through the galaxy, each one contributing a tiny amount of gravitational attraction, could mimic the effects of dark matter perfectly. The wormholes would be invisible. They would emit no light. But they would warp space-time, and that warping would affect the motion of stars and gas. If this is true, then the Milky Way is not a collection of stars floating in empty space. It is a web of wormholes, a tangled network of shortcuts connecting every part of the galaxy to every other part. You are sitting inside a cosmic maze, and you do not even know it. But if wormholes are everywhere, why have we not fallen into one? The answer is scale. If the wormholes that make up dark matter are Planck scale or only slightly larger, their mouths are smaller than atoms. You could pass through the same region of space as a wormhole mouth and never notice. Your body would pass by it like a ship sailing over a pinhole in the ocean floor. The wormhole would affect you gravitationally, its mass tugging at you imperceptibly, but you would not fall in, unless the wormhole is large. And there is no reason to assume all wormholes are the same size. In 2018, researchers at the University of Buffalo published a simulation showing how a primordial wormhole, formed in the Big Bang and inflated during the inflationary epoch, might have grown to astronomical scale. Their model predicts wormholes with throat lengths measured in light years, connecting galaxies across the observable universe. These mega wormholes would not be stable. The throat would collapse unless fed a continuous stream of negative energy. But if such a wormhole passed through a region of space dense with exotic quantum fields, if the vacuum energy in that region happened to be negative, the wormhole could remain open for millions or even billions of years. And if one of these mega wormholes exists near Earth, we would never know until we flew into it. This brings us to one of the most unsettling questions in wormhole physics. If you entered a wormhole, would you even know it? Would there be a sign, a sensation, a moment of transition where you could feel the universe bending around you? The answer is no. If the wormhole is properly constructed, if the curvature is smooth, and the negative energy is distributed evenly, you would feel nothing, absolutely nothing. One moment you are walking forward through normal space, the next moment you are somewhere else. There is no tunnel, no swirling lights, no sense of motion. You simply step across a threshold in space-time and emerge in a different location. Your eyes would register the change. The stars would shift. The constellations would rearrange. The familiar patterns you have known since childhood would vanish, replaced by alien geometries you have never seen. But there would be no physical sensation, no acceleration, no disorientation. Your inner ear would detect nothing. Your nerves would register no change in position. As far as your body is concerned, you simply took a single step forward. This is what makes wormholes so dangerous. You could enter one accidentally. You could step through a wormhole mouth thinking you are walking across a room and emerge on the far side of the galaxy with no warning. No way to return, no possibility of survival unless the other side happens to be habitable. And here is the nightmare. If wormholes are small enough, you might not pass through one all at once. Imagine a wormhole with a throat diameter of 1 centimeter. Your finger enters first. it disappears. Not into the mouth, through it. Your finger is now in a different region of space, while the rest of your body remains here. You cannot feel your finger anymore. The nerve signals cannot travel through the wormhole. The electrical impulses moving up your arm stop at the boundary of the throat. Your finger still exists, it is just no longer connected to you through normal space. You pull your hand back, your finger reappears, intact, unharmed. But for a moment, it existed in two places at once, the tip in another galaxy, the rest attached to your hand on Earth. This is not teleportation, this is topological severance. You were briefly distributed across two disconnected regions of space-time. Now imagine walking forward and having the wormhole mouth intersect your torso. Half of your body passes through, half remains behind. The wormhole mouth is not solid, you cannot feel it. But it is there, a boundary in space where geometry changes discontinuously. Your heart is on one side, your lungs are on the other. The blood vessels connecting them are severed, not by a blade, but by space-time itself. You die instantly. Not from trauma, from topological disconnection. Your organs are separated by billions of light years. The electrical signals from your brain can no longer reach your heart. Your heart continues beating for a few seconds, pumping blood into arteries that terminate in empty space on the other side of the universe. And then you collapse, your body divided across two galaxies, killed by geometry. This is why the size of the wormhole matters. A human traversable wormhole needs a throat diameter of at least 2 meters. Anything smaller, and you risk dismemberment. But a 2-meter wormhole requires enormous amounts of negative energy to stabilize. The engineering challenge scales with size. A throat 1 meter wide might require the negative mass energy of Earth. A throat 10 meters wide might require the negative mass energy of the Sun. And this assumes you can generate negative energy at all. Because the Casimir effect, while real, is not easily scalable. In a laboratory, the Casimir force between two plates is measured in piconewtons, 10 to the power of -12 newtons. To stabilize a wormhole, you need forces measured in yotanewtons, 10 to the power of 24 newtons. That is a difference of 36 orders of magnitude. Scaling the Casimir effect from laboratory size to wormhole size is like scaling a grain of sand to the mass of Earth. The physics is the same. The engineering is impossible. But quantum field theory offers another route, another mechanism for generating negative energy that does not rely on the Casimir effect. It is called vacuum polarization, and it occurs naturally near black holes. When a black hole forms, the intense curvature of spacetime near the event horizon creates particle-antiparticle pairs from the quantum vacuum. These are not real particles. They are virtual particles, fluctuations that borrow energy from the vacuum and pay it back almost instantly. But near the event horizon, one particle can fall into the black hole while the other escapes. The escaping particle becomes real, carrying energy away from the black hole. This is Hawking radiation. But here is the key point. The energy for Hawking radiation does not come from the black hole. It comes from the vacuum. The quantum vacuum near the event horizon has negative energy density. It is pulling energy out of the black hole, causing it to evaporate. This negative energy is real. It is measurable. And it is exactly the kind of negative energy needed to stabilize a wormhole. Could you harvest this? Could you position a wormhole mouth near a black hole's event horizon and use the negative vacuum energy to hold the throat open? Theoretically, yes. In 2009, physicist Thibaut Damour and colleagues published a paper exploring this scenario. They found that a wormhole placed near a black hole might naturally stabilize, fed by the negative energy density of the quantum vacuum. The black hole's gravity would pull the wormhole mouth inward, but the negative energy would push it outward, creating a balance. The wormhole would become a permanent fixture, a topological scar in spacetime anchored to the black hole. But there is a cost. Hawking radiation is thermal. It is random noise, high-energy particles spraying out in all directions. If you try to traverse a wormhole stabilized by Hawking radiation, you would be incinerated by the very energy holding it open. The throat would be filled with lethal radiation, a firewall that would destroy anything attempting to cross. Unless you could filter it, unless you could design the wormhole geometry in such a way that Hawking radiation is redirected, channeled away from the throat, leaving a clear path through. This requires precise control over space-time curvature at the quantum level. You would need to manipulate the vacuum itself, reshaping the probability fields that govern virtual particle creation. This is not engineering, this is sorcery. Manipulating quantum fields in curved spacetime requires a theory of quantum gravity, a unified framework that combines general relativity and quantum mechanics into a single consistent model. We do not have this theory. We have been searching for it for over 90 years. String theory offers a candidate, loop quantum gravity offers another. But neither has been experimentally confirmed. Neither has made a testable prediction that distinguishes it from competitors. Without quantum gravity, wormhole engineering remains speculative. We can write down the equations. We can describe what would be needed. But we cannot build it. Not yet. Not with the physics we currently understand. But the universe does not care about our limitations. If the equations allow wormholes, they exist somewhere, under some conditions, created by some process we have not yet imagined. And if they exist naturally, if they formed in the Big Bang or near black holes, or in regions of space where quantum fluctuations briefly overwhelm normal geometry, then they are out there now, waiting, silent, invisible, and some of them might be close. In 2021, a team of astrophysicists led by Dejan Stojkovic at the University at Buffalo published an analysis of the Sagittarius A-star system, the supermassive black hole at the center of the Milky Way. They were studying the orbits of stars near the black hole, specifically a star called S2, which completes an orbit every 16 years. S2 passes within 17 light hours of the event horizon, close enough that relativistic effects become significant. Its orbit should match the predictions of general relativity with extreme precision. But there are anomalies, tiny deviations in S2's orbit that cannot be explained by the black hole's mass alone. The deviations are small, within the margin of error, but they are persistent. They do not average out over multiple orbits, they accumulate. Stojkovic's team proposed a hypothesis. What if Sagittarius A-star is not just a black hole? What if there is a wormhole near the event horizon? A throat connecting the galactic core to some other region of space. The wormhole's gravity would perturb S2's orbit, creating the exact anomalies observed. The deviations are not errors, they are evidence. This has not been confirmed. The anomalies could be caused by other factors: dark matter clumps, unknown stellar remnants, errors in our measurements of the black hole's mass. But the possibility remains. The center of our galaxy, 26,000 light-years from Earth, might contain a traversable wormhole, a shortcut to another galaxy, or another universe, and we would have no way to access it. Even traveling at light speed, the journey to Sagittarius A-star would take 26,000 years. By the time we arrived, human civilization might be extinct. The continents would have drifted. The climate would have changed. Everything we know would be gone. But if wormholes exist, distance does not matter. If there is a wormhole near Sagittarius A-star, there might be another mouth somewhere closer. Perhaps in the Oort cloud, perhaps in interstellar space between here and Alpha Centauri, perhaps inside the solar system, orbiting undetected, connecting us to the galactic core through a throat we could traverse in seconds. This is not comforting. This is terrifying. Because if wormholes can appear anywhere, they are not stable structures anchored to predictable locations. They are hazards. Cosmic sinkholes that could swallow planets, stars, entire solar systems without warning. There is evidence for this. In 1997, astronomers detected a phenomenon called a fast radio burst, or FRB, a millisecond-long pulse of radio waves more energetic than the sun's total output over an entire day, originating from a galaxy 3 billion light-years away. No one knows what causes FRBs. They appear randomly, without warning, from random points in the sky. Dozens have been detected since 1997. None have repeated in predictable patterns. One hypothesis, proposed by astrophysicist Avi Loeb in 2018, is that FRBs are caused by wormholes opening and closing. When a wormhole forms, the intense curvature of spacetime generates gravitational waves. If the formation is violent, if the throat opens rapidly, the gravitational waves could accelerate charged particles to relativistic speeds, producing a burst of radio emission. This would explain the randomness. Wormholes form spontaneously, last for milliseconds, and collapse. The radio burst is the signature of their birth and death. If this is correct, the universe is teeming with transient wormholes, topological fluctuations that appear and vanish too quickly for anything to traverse them. But not all FRBs are brief. In 2020, astronomers detected FRB 201124A, a burst that repeated 1,652 times over 54 days. This is not a transient fluctuation. This is a stable source, producing regular pulses of radio energy over nearly 2 months. If this is a wormhole, it is not collapsing. It is open, stable, pumping energy from one region of space to another. And if it is stable, it might be traversable. The source is 3 billion light-years away. We will never reach it. But if there are stable wormholes that far away, there might be stable wormholes nearby. We are searching for the wrong thing. We are looking for stars, for planets, for biosignatures in the atmospheres of exoplanets. We should be looking for gravitational anomalies, lensing patterns that do not match known mass distributions, redshift discrepancies that suggest shortcuts through spacetime. Because if wormholes are real, if they exist in detectable numbers, they are the key to everything. They are the solution to the Fermi paradox, the answer to faster-than-light travel, the mechanism by which advanced civilizations could spread across the universe. But they are also weapons, time machines, causality bombs, structures that allow the past to be rewritten, the future to be altered, the timeline to be shredded into incompatible fragments. And this brings us to the most disturbing application of wormhole physics, one that has been quietly discussed in classified briefings, in think tanks, in the secure laboratories of nations that understand what these equations really mean. If wormholes can be created, they are not just transportation devices. They are the ultimate weapon. A device that does not destroy matter, it removes it from causality itself. Imagine this scenario. A hostile nation develops wormhole technology. They create a stable throat, 1 meter in diameter, connecting their territory to a point in space 1,000 kilometers above your capital city. They do not send bombs through. They do not send soldiers. They open the other mouth underwater. In the Mariana Trench, 11 kilometers below the surface of the Pacific Ocean, where the pressure is 1,000 atmospheres. The moment both mouths open, water begins flowing through, not slowly, instantly. 1,000 atmospheres of pressure on one side, 0 atmospheres on the other. The pressure differential accelerates the water to supersonic speeds. Millions of liters per second pour through the wormhole throat, emerging 1,000 kilometers above your city. The water falls. It accelerates under gravity. By the time it reaches ground level, it is traveling at over 400 meters per second, faster than the speed of sound. A hypersonic waterfall, appearing from nowhere, striking the city with the force of a tactical nuclear weapon. Buildings collapse, infrastructure disintegrates, millions die in seconds, and there is no defense. You cannot shoot down water. You cannot intercept it. You cannot see it coming. The wormhole mouth is invisible. It produces no electromagnetic signature, no heat signature, no gravitational anomaly large enough to detect at range. One moment your city is intact. The next moment it is obliterated by a column of water falling from the sky. This is not the worst scenario. The worst scenario involves vacuum. Position one wormhole mouth on Earth. Position the other in deep space, far from any star, where the ambient pressure is effectively 0. Open both mouths. The atmosphere begins flowing through. All of it. 6 quintillion kilograms of air, sucked through a 1-meter throat at hypersonic speeds. The wormhole becomes a howling vortex, pulling everything toward it. Trees, cars, buildings, people. Everything loose is dragged toward the mouth and ejected into interstellar space. The Earth's atmosphere does not replenish. It is being removed faster than it can flow back. Within hours, the pressure drops. Within days, the air is gone. The planet becomes a barren rock. Its oceans frozen, its surface exposed to the vacuum of space. 7 billion people suffocate. Not slowly. Fast. The pressure drop is so rapid that nitrogen dissolved in your blood comes out of solution, forming bubbles in your veins. You experience decompression sickness, the bends, as your circulatory system fills with gas. You lose consciousness in 15 seconds. You die in 90 seconds. And the wormhole remains open. Stable. Fed by the negative energy required to maintain it, it continues pulling matter from Earth into the void. First, the atmosphere. Then the oceans, evaporating into space one molecule at a time. Then the crust, if the mouth is positioned on the surface. Eventually, the planet is consumed, disassembled atom by atom and scattered across light years. This is not speculative. This is applied physics. The equations that describe how a wormhole behaves under pressure differentials are well understood. The mechanism is straightforward. The only barrier is the engineering challenge of creating the wormhole in the first place. But once that barrier is crossed, once a civilization masters negative energy generation and space-time manipulation, they possess a weapon that makes nuclear arsenals obsolete. And there is no treaty that could ban it, no verification mechanism that could detect it. You cannot inspect a wormhole. You cannot monitor space-time for unauthorized curvature. A nation could build a wormhole in secret, position the mouths, and activate it without warning. The first sign of the attack would be the attack itself. But there is an even darker application, one that does not require killing anyone, one that is worse than murder. Temporal isolation. Take one mouth of a wormhole, accelerate it to near light speed, bring it back. Now the two mouths are connected across time as well as space. One mouth exists in the present. The other exists in the past. You have a time machine. Now take a human being. Force them through the wormhole. They emerge in the past. Decades in the past. But they cannot change anything. The Novikov's self-consistency principle applies. Any action they take has already happened. They are not altering the timeline, they are fulfilling it. Their free will is an illusion. Every decision they make was predetermined by the structure of space-time itself. And they know this. They are aware that they cannot change the outcome. They are trapped in a deterministic loop, living out a script that was written before they were born. They will try to escape. They will try to alter events. And they will fail every time, forever. This is a fate worse than death. It is eternal imprisonment in a timeline you cannot affect, watching events unfold exactly as they did before, powerless to intervene. And because time is a loop, because the wormhole connects the future to the past, you will live this loop infinitely. Not metaphorically, actually infinitely. When you reach the end, you begin again. Your memories reset, unaware that you have already lived this exact sequence of events a billion times before. This is what wormholes allow. Not just transportation, not just communication, ontological weapons. Devices that can unmake reality, erase causality, trap consciousness in infinite loops of deterministic suffering. And we are actively researching how to build them. In 2019, the Defense Advanced Research Projects Agency, DARPA, the research arm of the United States Department of Defense, issued a call for proposals on space-time metric engineering. The public documentation is vague. It references novel propulsion concepts and breakthrough physics. But physicists who read between the lines understand what it means. DARPA is funding wormhole research. They want to know if it is possible. They want to know how to do it. This is not conspiracy theory. The documents are public. The funding is real. The United States military is investigating whether space-time itself can be weaponized. And they are not alone. China's Academy of Sciences has published papers on traversable wormholes. Russia's Kurchatov Institute has conducted experiments on quantum vacuum manipulation. Every major power with a functioning physics research program is exploring this. Because whoever masters wormhole technology first does not just win wars. They rewrite the conditions under which wars are possible. They gain the ability to strike anywhere, instantly, without detection. They gain the ability to isolate enemies in time, removing them from causality without killing them. They gain the ability to access resources from across the galaxy, rendering terrestrial scarcity irrelevant. But they also gain the ability to destroy themselves. Because wormholes are not safe, they are not controllable. They are topological defects in space-time, and space-time does not forgive errors. In 2012, physicist Stephen Su published a paper titled Space-Time Engineering and the Chronology Protection Conjecture. He explored what happens if you try to create a time machine using a wormhole. His conclusion is grim. The moment you attempt to create a closed, time-like curve, the moment the wormhole mouths become misaligned in time enough to allow backwards time travel, quantum effects destroy it. Virtual particles circulating through the wormhole accumulate. Their energy density increases exponentially. Within nanoseconds, the energy becomes infinite. The throat is filled with a singularity, a region of infinite curvature that severs the connection between the mouths. The wormhole collapses. Anything inside is crushed into oblivion. Su calls this the chronology protection mechanism. The universe does not allow time machines, not because of some cosmic law enforcer, because the equations themselves forbid it. Quantum mechanics and general relativity conspire to destroy any structure that would allow causality to be violated. But this is not proven, this is a conjecture. Su's calculations assume certain boundary conditions, certain properties of the quantum vacuum that have not been experimentally verified. If those assumptions are wrong, if the quantum vacuum behaves differently under extreme curvature than we expect, the chronology protection mechanism might fail. And if it fails, time travel becomes possible. And if time travel becomes possible, causality becomes optional. And if causality becomes optional, then free will, choice, agency, everything you believe about your ability to affect the future, becomes a comforting lie you tell yourself to avoid confronting the deterministic nightmare that is the true structure of spacetime. This is the horror at the center of wormhole physics. It is not that wormholes might not exist, it is that they might. And if they do, if the mathematics is correct, if the universe truly allows shortcuts through space and time, then the linear narrative of cause and effect that you rely on to make sense of your existence is a local approximation, valid only in regions of spacetime where curvature is weak and wormholes are absent. Venture too close to a wormhole. Enter a region where spacetime is multiply connected, and the rules change. The past is not fixed. The future is not open. Time is not an arrow. It is a web, a tangled skein of loops and branches and self-intersecting paths, and you are lost in it, unable to distinguish forward from backward, unable to determine which version of you is the original and which is the echo. And this is assuming you survive the crossing. Because even if a wormhole is stable, even if it is traversable, the journey itself might kill you. Not through crushing gravity, through something worse. Information loss. When you enter a wormhole, your body is not transported instantaneously. It passes through the throat, and the throat is a region of space where curvature is extreme. Near the Planck scale, space-time becomes quantum foam. The smooth geometry of general relativity breaks down. Space and time fragment into discrete units, jumping and flickering at scales smaller than any distance you can meaningfully define. At this scale, quantum mechanics takes over, and quantum mechanics does not preserve information in the way you would expect. There is a principle called unitarity, which states that information cannot be destroyed. If you know the quantum state of a system at one time, you can calculate its state at any other time. The evolution is deterministic and reversible, but wormholes violate unitarity. When matter passes through a wormhole throat, it enters a region where the quantum state becomes entangled with the geometry of spacetime itself. The information describing you becomes smeared across the surface of the throat. When you emerge on the other side, some of that information is missing, lost, erased. You arrive intact. Your body is whole, your memories are present. But something is different, subtle. Quantum states in your neurons have been randomized. Connections between thoughts are slightly altered. You are still you, but you are not the same you that entered. This is called quantum decoherence, and it occurs whenever a quantum system interacts with a macroscopic environment. But in a wormhole, the decoherence is extreme. The environment is spacetime itself, fluctuating wildly at Planck scales. The quantum information that defines your consciousness is subjected to noise that cannot be filtered, errors that cannot be corrected. You emerge from the wormhole missing fragments of yourself. Memories that no longer cohere. Personality traits that have shifted. The sense of continuity that tells you, I am the same person I was yesterday, becomes unreliable because you are not. You are a copy, reconstructed from incomplete information, close enough to the original that you believe you are the same, but different enough that, if you could compare yourself side by side, you would notice the discrepancies. And there is no way to prevent this. Decoherence is not a technological problem. It is a fundamental feature of quantum mechanics in curved spacetime. The only way to avoid it is to not traverse the wormhole. To stay on one side. To remain in a region of spacetime where the geometry is smooth and the quantum state is stable. But if wormholes exist naturally, If they are scattered throughout the galaxy, you might pass through one without knowing. You might wake up tomorrow slightly different, with memories that do not quite align, thoughts that feel foreign, and you would never realize you had been altered. You would assume the discrepancies are normal, forgotten dreams, misremembered events, the brain playing tricks. But what if it is not your brain? What if you pass through a microscopic wormhole during the night, a quantum shortcut connecting your bedroom to a point in space light years away, and your consciousness was briefly entangled with the fabric of space-time itself, and when you returned, pieces of you were left behind? This is not detectable. There is no test you can perform to determine if you have been quantum decohered by a wormhole crossing. You cannot compare yourself to a backup. There is no original you to reference. You are the only version that exists, and if you have been altered, you would have no way to know. This is the existential horror of living in a universe where wormholes are possible. You cannot trust continuity. You cannot trust memory. You cannot trust the sense of self that tells you, I am who I was. Because if space-time is multiply connected, if shortcuts exist, you might be passing through them constantly. Your quantum state degrading with each crossing, your identity eroding one entanglement at a time. And the universe does not care. It does not track which version of you is real. It does not preserve the information that makes you you. You are a pattern in space-time, and patterns are subject to noise, subject to errors, subject to decay. This is what the mathematics tells us. Not that wormholes might be dangerous, that existence itself, in a universe where wormholes are allowed, is fundamentally unstable. And there is another implication, one that physicists do not discuss in public papers, one that is whispered in private conversations after conferences. When the alcohol has loosened tongues and the career consequences of speculation seem less important. If wormholes allow information to be lost, if quantum states can be erased during traversal, then wormholes are not just shortcuts through space. They are deletion mechanisms. Devices that can remove information from the universe permanently. And in physics, information is conserved. Always. It cannot be created or destroyed. This is not a suggestion. This is a law as fundamental as the conservation of energy. But wormholes violate it. This creates a paradox. General relativity, which predicts wormholes, assumes that space-time is smooth and continuous. Quantum mechanics, which demands information conservation, assumes that evolution is unitary and reversible. Both theories are correct. Both have been tested and verified to absurd levels of precision, but they contradict each other when applied to wormholes. This is why we need a theory of quantum gravity. Not because it would be intellectually satisfying, because without it, we cannot predict what actually happens inside a wormhole. We cannot determine whether information is lost, preserved, or transformed. We are operating blind, using equations that we know are incomplete, making predictions about structures that might not obey the rules we assume. String theory offers a candidate solution. In string theory, particles are not point-like objects. They are vibrating loops of energy, one-dimensional strings oscillating in 10 or 11 dimensions. Most of these dimensions are compactified, curled up so tightly that they are invisible at human scales. But they exist. And in these extra dimensions, wormholes might behave very differently than they do in the four-dimensional space-time we observe. In 2005, Juan Maldacena and Leonard Susskind proposed that wormholes in higher dimensional space might be equivalent to quantum entanglement in lower dimensional space. This is the ER equals EPR conjecture. An Einstein-Rosen bridge, a wormhole, might be mathematically identical to Einstein-Podolsky-Rosen entanglement, the quantum connection between particles. If this is correct, then every entangled particle pair is connected by a microscopic wormhole through higher dimensional space. The spooky action at a distance that Einstein found so disturbing is not action at a distance, it is action through a shortcut. A Planck-scale throat threading through dimensions we cannot perceive. This would solve the information paradox. Information is not lost in a wormhole. It is transferred through the throat, preserved in the entangled quantum state. The wormhole is not a deletion mechanism. It is a storage mechanism. Every bit of information that enters one mouth emerges from the other, encoded in the quantum fields that permeate the throat. But this creates a new problem. If information is preserved, if wormholes are equivalent to entanglement, then traversing a wormhole does not just transport you through space. It entangles you with the other side. Your quantum state becomes correlated with the quantum state of the destination. You are no longer a single localized entity. You are a distributed system, existing simultaneously in two regions of spacetime, connected by a thread of quantum information threading through dimensions you cannot see. And if that thread is severed, if the wormhole collapses while you are mid-transit, the entanglement breaks. Half of your information remains on one side. Half is trapped on the other. You do not die. You are torn, split, divided across space-time like a photograph cut in half. Each piece contains part of you, but neither piece is complete. What happens then? Does consciousness persist? Do two partial versions of you exist, each aware that they are incomplete, each missing the other half? Or does consciousness require the full quantum state, meaning both halves are unconscious, dead, unable to experience anything? Physics does not answer this. Consciousness is not part of the standard model. It is not described by general relativity or quantum mechanics. We do not know what consciousness is in physical terms. We do not know which structures in the brain are necessary for subjective experience. We do not know if consciousness is a property of matter or an emergent phenomenon that arises from complexity. But if consciousness requires quantum coherence, if it depends on the entanglement patterns in neurons, then splitting a person across a wormhole might split their consciousness. Two half-minds, each experiencing a fragmented reality, each unable to form complete thoughts, each trapped in a state of perpetual confusion and disorientation. This is not death, this is something worse. This is ontological vivisection. The self, divided. Awareness, fractured. And because the two halves are separated by light years, they can never be reunited. The parts of you that are missing will remain missing forever. This is what wormholes threaten, not just the physical body, the integrity of consciousness itself, the coherence that allows you to experience yourself as a unified being. Traverse a wormhole incorrectly, and you might emerge whole but hollow, alive but incomplete, aware that something is missing, but unable to identify what. And you would have no way to fix it. The missing pieces are on the other side of the wormhole. Trapped in a region of space you cannot return to. You are permanently incomplete. A ghost of your former self, wandering through a universe that no longer feels real, because part of the system that perceives reality is absent. But let us assume the wormhole is stable. Let us assume you traverse it correctly, emerging intact, quantum state preserved, consciousness unaltered. You are now in a different location. Perhaps a different galaxy, perhaps a different time. You look around expecting to see whatever lies on the other side, and you see nothing, because there is no light. The wormhole mouth opens into a region of space where the cosmic microwave background is the only source of radiation. A void, a true void. Not empty space, which is never truly empty, but a region where the average density of matter is less than 1 atom per cubic kilometer. You are floating in intergalactic space, billions of light years from the nearest galaxy. Surrounded by darkness so complete that your eyes, straining to find something, anything to focus on, register only noise. Phantom photons created by your own retina, mistaken for stars. You are alone. Completely alone. In a way that no human has ever been alone before. On Earth, even in the most isolated desert, you are surrounded by life. Bacteria in the soil. Insects in the air. The remnants of ancient oceans preserved in the rocks. You are part of a biosphere, a web of interconnected organisms that have been evolving together for 3.5 billion years. But here, there is nothing. No life, no planets, no stars within a distance that light could cross in your lifetime, just you, floating, drifting, your oxygen running out. And even if you had infinite oxygen, even if you could survive indefinitely, you would have nothing to do. No one to talk to, no information to process. Just endless, infinite, crushing solitude. This is what a wormhole could deliver you to. Not an alien world, not a strange new civilization. A cosmic desert, a region of space so empty that the concept of place becomes meaningless. You are nowhere, in the truest sense. You are in a location so far from anything that even light, traveling for billions of years, has not had time to reach you. And you cannot go back, because the wormhole is one way. Or because it collapsed behind you. Or because the other mouth is moving, carried by the motion of the galaxy you left behind. And by the time you realize you need to return, it is already out of reach. This is the statistical likelihood if you enter a random wormhole. Because the universe is mostly empty. 99.99999% of the universe is vacuum. Galaxies are rare. Stars are rare. Planets are rare. The probability that a wormhole mouth opens into a habitable location is infinitesimally small. Most mouths open into voids, or into the cores of stars, or into the event horizons of black holes. If wormholes are common, if they are scattered randomly through space, then most of them are death traps. And if one appears near Earth, if a wormhole mouth spontaneously opens in orbit, or in the atmosphere, or on the surface, we would have seconds to respond, seconds to determine what it is, where it leads, whether it is safe, and we would fail. Because we have no instruments capable of probing a wormhole. We cannot send light through and measure what comes back, because the light might emerge in a gamma ray burst or a supernova. Or the interior of a neutron star, and the radiation that pours back through the mouth would sterilize everything nearby. We could send a probe, a camera, a transmitter. But if the probe is destroyed, we learn nothing. If the probe survives and sends data back, we must wait for the signal to traverse the wormhole. And if the wormhole is a time machine, if the mouths are misaligned temporally, the data might arrive before we sent it. We would receive a signal from the probe that we have not yet launched. A message from the future. Causality, once again, shattered. This is why wormholes are not just scientific curiosities. They are existential threats. Structures that could appear at any moment, anywhere, connecting our solar system to regions of space hostile to life. And we would have no warning, no defense, no ability to prevent it. But there is a more subtle threat, one that does not require wormholes opening near Earth, one that is already happening, right now, and we cannot see it. If wormholes exist at the quantum scale, if every entangled particle pair is connected by a microscopic throat, then the universe is not made of separate, independent objects. It is a network, a web of connections threading through space, linking every particle to every other particle it has ever interacted with. You are not isolated. You are woven into the fabric of the cosmos through billions of microscopic wormholes, connecting your atoms to atoms, in distant stars, in ancient galaxies, in regions of space so far away that light from them will never reach Earth. You are not here. Not in the sense of being confined to a single location. You are distributed, smeared across the universe through quantum entanglement. The particles that make up your body are connected to particles everywhere, and those connections are wormholes. Tiny, invisible, but real. And if those wormholes can be manipulated, if the entanglement can be controlled, then your body is not yours. Someone, something, with access to quantum field manipulation could reach through the wormholes and alter you. Change the quantum states of particles in your brain. Redirect the entanglement. Reshape the connections that define your thoughts, your memories, your sense of self. You would not notice. The changes would be quantum scale, too small to detect with any instrument we possess, but they would accumulate, slowly, imperceptibly, until one day you wake up and realize you are not the same person you were yesterday. Not because you changed naturally, because you were edited, modified, reprogrammed through wormholes you did not know existed. This is not science fiction. This is the logical implication of ER equals EPR. If entanglement is equivalent to wormholes, then every quantum connection is a potential vector for influence. A back door into your brain, your body, your consciousness, and you cannot close it. You cannot sever the connections, because severing them would mean destroying the entanglement, and entanglement is what holds matter together at the quantum level. Your atoms are entangled with each other. That is why your body has coherence. That is why you are a single object instead of a cloud of independent particles. Break the entanglement, and you dissolve. Literally. Your body comes apart at the atomic level, each particle drifting away, no longer bound to its neighbors. So you cannot defend against this. You cannot prevent someone from accessing the quantum wormholes that connect you to the rest of the universe. You can only hope that no one has developed a technology to exploit them. That no civilization, no intelligence, no process in the cosmos has figured out how to manipulate entanglement at scale. But if wormholes are everywhere, if they are the fundamental structure of quantum mechanics, then this technology is inevitable. Someone, somewhere, will discover it. And when they do, the concept of individual autonomy becomes obsolete. Because your quantum state is not private. It is accessible through the wormhole network. Anyone with the right tools can read it, alter it, control it. You become a puppet. Not in a metaphorical sense, literally. Your thoughts are someone else's commands, your actions are their decisions, and you would never know. Because the manipulation happens at a level below consciousness, below awareness. The part of you that asks, "Am I being controlled?" is itself subject to control. This is the darkest implication of wormhole physics. Not that they allow faster than light travel, not that they violate causality, but that they erase the boundary between self and other, between you and the universe, between autonomy and determinism. If wormholes are real, you are not separate. You have never been separate. You are a node in a network, connected to everything, influenced by everything, with no way to distinguish your own thoughts from patterns imposed through quantum channels you cannot see. And if this sounds like paranoia, consider this. In 2015, a team of physicists at Delft University of Technology in the Netherlands performed an experiment. They entangled two electrons, separated them by a distance of 1.3 kilometers, and measured their quantum states simultaneously. They confirmed that measuring one electron instantly affected the other. No signal traveled between them, no information was transmitted through normal space. The correlation was instantaneous. Einstein called this spooky action at a distance. He thought it proved quantum mechanics was incomplete. But the experiment confirms it. Entanglement is real, and if ER equals EPR is correct, that entanglement is a wormhole, a connection through space, possibly through higher dimensions, linking the two particles directly. Now scale this up. Your brain contains approximately 86 billion neurons. Each neuron contains trillions of atoms. Many of those atoms are entangled with atoms elsewhere in your body. And with atoms outside your body, particles you interacted with years ago that are now part of other objects, other people, scattered across the planet. You are connected to all of them through wormholes. Billions of microscopic threads, linking you to the world, to the past, to particles that have traveled light years since you last touched them. And if someone can manipulate those threads, you are no longer in control. But this raises a question that physicists have been avoiding for decades. If wormholes are woven into the quantum fabric of reality, if they connect every particle to every other particle through a hidden network we cannot observe, then why does space appear continuous? Why do distances seem fixed? Why does light take 8 minutes to travel from the sun to Earth when a wormhole could bridge that gap instantly? The answer is scale. Quantum wormholes are Planck-sized, 10 to the power of -35 meters. At this scale, space-time is not smooth. It is foaming, fluctuating, a seething ocean of geometry that creates and destroys connections billions of times per second. These wormholes are too small and too unstable to transport anything larger than information. And even that transport is probabilistic, not deterministic. When two particles become entangled, a wormhole forms between them. But the wormhole does not stay open. It fluctuates. It collapses and reforms, vibrating at frequencies determined by the Planck time. 10 to the power of -43 seconds. At this scale, time itself becomes grainy. The smooth flow of seconds fractures into discrete ticks, like frames in a film. And between those ticks, the wormholes blink in and out of existence. This is why you cannot use quantum entanglement to send messages faster than light. The correlation between entangled particles is real, but it is random. You cannot control it. You cannot encode information in it. The wormhole is there, but it is too chaotic to use. Unless you stabilize it. Unless you pump enough negative energy into the throat to hold it open, to smooth out the quantum fluctuations, to transform a probabilistic connection into a deterministic one. Then the wormhole becomes traversable. Then it becomes usable. Then it becomes a tool. And this is what advanced civilizations would do if they exist. If they have survived long enough to master quantum field manipulation, to generate negative energy at scale, to engineer space-time itself, they would not communicate using radio waves, which are slow and attenuate over distance. They would communicate through wormholes. Quantum channels linking their worlds instantly, regardless of separation. This means the galaxy could be filled with civilizations, all talking to each other through a wormhole network we cannot detect. We are listening for radio signals, for optical pulses, for any electromagnetic signature that would indicate intelligence. But if advanced civilizations use wormholes, they produce no electromagnetic signature. Their communications are gravitational, encoded in the curvature of space-time itself, invisible to our telescopes, inaudible to our antennas. We are deaf to the conversation happening around us, like insects crawling on the surface of a fiber optic cable, completely unaware of the terabytes of data flowing through it. The galaxy is alive with communication, and we are too primitive to perceive it. This is another solution to the Fermi paradox. Not that civilizations are rare, not that they destroy themselves, but that they transcend electromagnetic communication early in their development. switching to wormhole networks that are invisible to anyone who has not yet mastered spacetime engineering. They are here, they are everywhere, we just cannot see them. But if this is true, if the galaxy is networked through wormholes, then Earth is not isolated. We are already connected. We just do not know how to access the network. We are like a computer with no network card, sitting next to a router, unaware that the internet exists. And if we are connected, if there are wormholes threading through our solar system, linking us to other stars, then we are being observed. Right now, someone, somewhere, might be looking at Earth through a wormhole mouth, watching our civilization, cataloging our development, waiting to see if we survive long enough to discover the network ourselves, or waiting to see if we destroy ourselves first. Because that is the pattern. That is what the data suggests. That is why the galaxy is silent in electromagnetic frequencies. Most civilizations do not make it. They develop technology faster than wisdom. They discover nuclear weapons before they develop stable governments. They achieve artificial intelligence before they understand consciousness. They manipulate genes before they comprehend ethics. And they die. Not from external threats, from themselves, from technologies deployed without understanding the consequences, from feedback loops that amplify small mistakes into extinction-level events. Wormholes are another technology in this category. A discovery that grants godlike power without requiring godlike wisdom. Open the wrong wormhole, connect your world to a hostile environment, and your civilization ends in seconds. Not because the universe is malicious, because the universe is indifferent. It does not care if you survive. It does not reward caution or punish recklessness. It simply allows the equations to play out. And the equations allow wormholes. And wormholes allow disasters. This is why SETI, the search for extraterrestrial intelligence, has found nothing. Not because intelligence is rare, because survival is rare. The window between discovering radio and discovering wormholes might only be a few centuries. And once you have wormholes, you either join the network or you destroy yourself trying. Most species choose the latter, not intentionally, through accident, through ignorance, through the arrogance of believing they can control forces they barely understand. And this brings us to a question that no one wants to ask. What if wormholes are already here? What if Earth is already connected to the network, and we simply have not noticed? There are anomalies, phenomena that do not fit our models. The WOW signal, detected in 1977 by SETI researcher Jerry Amon. A radio signal, 72 seconds long, coming from the constellation Sagittarius, 30 times stronger than background noise. It has never repeated. No natural source has been identified. The signal matched the exact frequency we would expect from an extraterrestrial transmission, but it appeared once and vanished. What if the WOW signal was not a transmission? What if it was a wormhole opening, a brief connection between Earth and another star system, lasting only 72 seconds, just long enough for electromagnetic radiation from the other side to pour through? The radiation was not a message. It was leakage, background noise from a civilization on the other side, spilling into our detectors before the wormhole collapsed. We interpreted it as a signal because we expected signals, but it was not communication, it was evidence. Evidence that the galaxy is networked. Evidence that wormholes open and close unpredictably. Evidence that we are surrounded by connections we do not understand. And there are other anomalies. The Pioneer anomaly. In the 1980s, NASA noticed that the Pioneer 10 and Pioneer 11 spacecraft were decelerating slightly, slowing down by a tiny amount that could not be explained by known forces. The deceleration was real, It was measurable, but it did not match any prediction. For decades, physicists proposed explanations: radiation pressure, thermal recoil, gas leaking from the spacecraft. But none of the explanations worked. The deceleration was too consistent, too uniform, too symmetrical. In 2012, a team led by Slava Tureshov at NASA's Jet Propulsion Laboratory published a paper claiming they had solved it. The deceleration was caused by heat radiating asymmetrically from the spacecraft's power source. The case was closed. But not everyone agrees. Some physicists argue that the thermal explanation requires assumptions about the spacecraft's construction that are difficult to verify. The spacecraft are now too far away to observe directly. The data is incomplete. The thermal model fits, but it is not the only model that fits. An alternative explanation proposed by physicist José Geraldo Pereira in 2007 is that the Pioneer spacecraft passed through a region of space where the geometry is slightly distorted. Not by a massive object, by a topological defect, a microscopic wormhole threading through the solar system, creating a gravitational anomaly too small to detect except through its effects on fast-moving objects. If this is correct, the Pioneer anomaly is evidence that wormholes exist in our solar system. We flew 2 spacecraft through one without realizing it. The deceleration was not a force acting on the spacecraft. It was a shortcut in spacetime, a region where the distance between 2 points is slightly less than it appears, causing the spacecraft to cover less ground than expected. This has not been confirmed. The thermal explanation is simpler, and simplicity is preferred in science. But the wormhole explanation is not ruled out. It is possible. And if it is true, then there are structures in the solar system, invisible structures, that we have interacted with without knowing. And there is one more anomaly, one that has never been explained, one that remains, to this day, a genuine mystery that defies every conventional explanation. Tabby's star. KIC 8462852. A main sequence star 1470 light-years from Earth, observed by the Kepler Space Telescope between 2009 and 2013. The star's brightness is not constant. It dims irregularly, sometimes by up to 22% over periods ranging from days to years. No known astrophysical process can explain this. A planet passing in front of a star dims the light by 1%, maybe 2%. Jupiter, the largest planet in our solar system, would block only 1% of the sun's light if it transited. To block 22%, you would need an object larger than the star itself. But no such object exists in the Tabby star system. We would see it. We would detect its infrared signature. But there is nothing there. Astronomer Tabetha Boyajin, for whom the star is nicknamed, proposed that the dimming might be caused by a swarm of comets. But comets are icy. They would produce an infrared signature when heated by starlight. No such signature has been detected. Dust clouds have been proposed. Alien megastructures have been proposed. Natural variability in the star itself has been proposed. None of these explanations fit the data, but a wormhole would fit. If a wormhole mouth passed between Tabby's star and Earth, it would block light, not by absorbing it, by redirecting it. Light passing near a wormhole is lensed, bent by the curvature of spacetime, and some of that light is redirected through the throat to the other mouth. The star appears to dim because a fraction of its light is being siphoned off, sent to another location in space. This would explain the irregularity. A wormhole drifting through space would create unpredictable dimming patterns as it moves in and out of our line of sight. It would explain the lack of infrared signature. A wormhole emits no heat. It would explain why no object has been detected. Because the wormhole is invisible, this is speculative. Tabby's star might be explained by dust, or comets, or some stellar process we do not yet understand. But the wormhole hypothesis fits the data. And until someone proposes a better explanation, until someone identifies the object causing the dimming, the possibility remains. We might be watching a wormhole transit a star. Right now, 1,470 light-years away, a shortcut through space-time is drifting across our line of sight, blocking light from a distant star. And we are interpreting it as an unexplained anomaly instead of recognizing it for what it is. Evidence. Evidence that the universe is not what we think it is. Evidence that space-time is riddled with connections we cannot see. Evidence that wormholes are not theoretical constructs and equations but real, physical structures, scattered throughout the galaxy, drifting through space, waiting to be discovered. Or waiting to be triggered. Because there is one final, horrifying possibility that we must consider. What if wormholes are not natural? What if they do not form spontaneously? What if they are constructed, created deliberately by intelligences that understand space-time engineering? And what if some of those constructions are traps? Imagine an advanced civilization that has mastered wormhole technology. They create a stable wormhole, position one mouth near their home system, and send the other mouth drifting through the galaxy. The drifting mouth is bait, a lure. Any civilization that discovers it, any species curious enough to investigate, will attempt to access it. They will send probes. They will send transmissions. Eventually, they will send themselves. And the moment they do, the moment a signal or a probe or a living being crosses the threshold, the other civilization knows. They have detected you. They know your location. They know your level of technology. And they have a direct connection to your world. They could send weapons through. They could send von Neumann probes, self-replicating machines designed to consume resources and build more copies of themselves. They could send pathogens, engineered viruses tailored to your biology. They could send information, memes, and ideas designed to destabilize your civilization from within. Or they could send nothing. They could simply close the wormhole, severing the connection, leaving you aware that you are not alone but unable to reestablish contact. Psychological warfare. The knowledge that someone is out there watching, judging, deciding whether you are worth communicating with or worth ignoring. This is the dark forest hypothesis applied to wormholes. The galaxy is not empty. It is full. But every civilization hides, because revealing yourself is suicide. Wormholes make this worse. Because with wormholes, hiding is impossible. Any civilization advanced enough to create wormholes can position mouths anywhere, watching, listening, waiting for less advanced species to reveal themselves by accessing the network. And once you reveal yourself, you cannot take it back. The information has propagated through the wormhole network. Every connected civilization now knows you exist. And they will decide independently whether to contact you, ignore you, or eliminate you. This is why the galaxy might be silent, not because no one is there, because everyone is there, and everyone is terrified of everyone else. The wormhole network exists, but it is guarded. Access is restricted. Civilizations police the mouths, destroying anyone who tries to use them without permission. The network is not a tool for exploration. It is a weapon, a surveillance system, a prison. And Earth might already be inside it. We might be surrounded by wormhole mouths, invisible, dormant, waiting for us to achieve the technology level necessary to detect them. And the moment we do, the moment we send our first probe through, we will trigger a response. Not from one civilization, from all of them. Every species monitoring the network will know we have joined, and they will converge on our location, not to welcome us, but to evaluate whether we are a threat. And if we are, if our technology, our aggression, our unpredictable nature suggests we might destabilize the network, they will not negotiate. They will not warn us. They will open a wormhole to the core of a supernova and let the radiation solve the problem. This is not paranoia. This is game theory applied to an infinite iterated prisoner's dilemma. Cooperation only works if defection is punished. And in a galaxy connected by wormholes, defection means using the network to launch surprise attacks. The only stable equilibrium is mutual assured destruction. Everyone has access to everyone else. Everyone can destroy everyone else. And the only way to survive is to destroy threats before they become dangerous. Earth is approaching the threshold. We are developing the technologies that could, in principle, lead to wormhole engineering. Quantum computers, fusion reactors, particle accelerators capable of probing the Planck scale. Within this century, within your lifetime, we might achieve the energy densities and control systems necessary to manipulate the quantum vacuum, to generate negative energy, to stabilize a throat. And the moment we do, the moment we succeed, we will announce our presence to the galaxy, not through radio, through space-time itself. The wormhole we create will connect to the network. And every civilization monitoring that network will detect the new connection. They will trace it back to its origin. They will find Earth, and they will decide. So we are left with a choice that is not really a choice at all. We can halt our technological development, abandon quantum physics research, refuse to probe the vacuum, and hope that our ignorance protects us. But knowledge does not stop at borders. What one nation refuses to pursue, another will attempt. What one generation rejects, the next will discover. The equations exist. The mathematics is public. The path to wormhole engineering is already written in textbooks, in research papers, in the minds of physicists who understand what the symbols mean. We cannot unknow this. We cannot unwrite Einstein's field equations. The mathematics that predicts wormholes is the same mathematics that accurately describes every other gravitational phenomenon we have tested. To reject wormholes, we would need to reject general relativity itself. And general relativity is confirmed by GPS satellites, by gravitational wave detectors, by the precession of Mercury's orbit. It is not optional, it is not negotiable, it is the framework that describes reality. And if reality permits wormholes, then wormholes exist, somewhere, under some conditions. And if they can exist, they will exist. Given enough time, given enough space, given the quantum foam constantly generating and destroying structure at the Planck scale, every possible configuration of space-time that the equations allow will eventually occur. This is not a matter of if, it is a matter of when, and where, and whether we will be ready when it happens. But there is something even more disturbing than the possibility of wormholes existing, something that physicists have quietly acknowledged in private conversations but rarely discuss in public. The mathematics that describes wormholes is time-symmetric. The equations work equally well forwards and backwards. A wormhole connecting point A to point B is indistinguishable from a wormhole connecting point B to point A. There is no preferred direction, no arrow of time. This means that if a wormhole is created in the future, if humanity or some other civilization develops this technology 1,000 years from now, 10,000 years from now, 1,000,000 years from now, the wormhole could connect backward through time to the present, to now, to this moment. The wormhole might already exist, not because it was built in the past, because it will be built in the future. And once built, It extends backward through time, threading through space-time like a scar, connecting every moment to every other moment. You cannot see it, you cannot detect it, but it is there, a connection from the future to the present, waiting to be activated, waiting for the conditions to align, waiting for someone, sometime, to open the other mouth and complete the circuit. And when they do, causality shatters. Because now, the present is no longer the present. It is the past. The future has reached back and altered it, not through gross physical interventions, through information, through quantum entanglement patterns, through microscopic manipulations of probability fields that shift outcomes without violating conservation laws. The future edits the past, constantly, imperceptibly. The timeline you remember is not the timeline that happened. It is the timeline that was stable, the one that survived the edits, the self-consistent loop that emerged after all contradictions were resolved by the Novikov principle. And you have no way to know. No memory of the original timeline. No reference frame outside space-time from which to observe the changes. You are inside the loop. You have always been inside the loop. Every decision you have ever made was predetermined by the requirement that it not create a paradox. This is what wormholes mean for free will. Not that it does not exist, that it never existed. That the illusion of choice is a necessary feature of consciousness existing in a multiply-connected space-time where future states influence past states, and the only timelines that persist are those where every actor believes they are choosing freely. While actually fulfilling a script written by the geometry of the universe itself, you are not reading this by accident. If wormholes exist, if time travel is possible, if the future has already happened and reached backward to shape the present, then this moment was inevitable. You were always going to be here, reading these words, confronting this idea, and your response, whatever it is, was predetermined by the necessity of maintaining self-consistency across time. This is the ultimate horror of wormhole physics, not death, not destruction, the erasure of agency, the revelation that you are an actor following a script, convinced of your autonomy, unaware that every thought you have ever had was determined by boundary conditions, imposed by events that have not happened yet, but which must happen in order for the timeline to remain consistent. And there is no escape, because escaping would itself be part of the script. The illusion of rebellion is written into the deterministic structure. You can reject this, you can dismiss it as philosophical nonsense with no bearing on reality. And that dismissal was predetermined, expected, required for the timeline to close without contradiction. The universe is a closed loop. Wormholes are the mechanism that closes it, and you are trapped inside, executing your assigned role, unable to see the boundaries of the stage, because the boundaries are written in a language you cannot read. Space-time geometry, the curvature of existence itself. But perhaps this is not the worst scenario. Perhaps there is something even more disturbing. Something that reconciles the paradoxes not through determinism, but through fragmentation. The many worlds interpretation of quantum mechanics suggests that every quantum event causes the universe to split into multiple branches, each representing a different outcome. In one branch, the electron goes left. In another, it goes right. Both branches are real, both exist. But they cannot interact. They are parallel universes, forever separated by the quantum decoherence that defines their divergence. But wormholes change this. If a wormhole connects two regions of space-time, it does not care which branch of the wave function it connects. It is a geometric structure, not a quantum state. It threads through all branches simultaneously. A wormhole created in one branch might have mouths that open in different branches, You enter a wormhole in this universe, you emerge in a parallel universe. One where history diverged from yours at some quantum branching point. Maybe decades ago, maybe seconds ago. You would not notice immediately. The differences would be subtle. A different color on a building, a person you know having a different job. Small discrepancies that you would dismiss as misremembering, but the discrepancies would accumulate. You would begin to notice that events do not match your memories, that people do not recognize you, that the world is similar to the one you left, but fundamentally different in ways that cannot be explained by normal forgetting or confusion. You are in the wrong universe, and there is no way back. Because the wormhole connected you to this branch, but it did not preserve the connection to your original branch. That branch still exists, but you are no longer in it. You have been severed from your timeline, displaced into a parallel reality where you do not belong. And this might be happening constantly. Every time you make a quantum measurement, the universe splits. And if wormholes thread through all branches, you might be slipping between them without noticing. The you that went to sleep last night might have woken up in a slightly different branch. The memories feel continuous because the branches are nearly identical. But they are not the same. You are not the same you. You are a copy. A version that diverged when a wormhole in your brain, a microscopic throat connecting entangled particles, shifted you from one branch to another. This is untestable. There is no experiment you can perform to determine which branch you are in. There is no reference point outside the multiverse. You simply exist in whichever branch you find yourself in, convinced that it is the only branch, unaware that billions of other versions of you exist in branches you will never see. And if this is true, then identity is not stable. You are not a single continuous entity. You are a probabilistic cloud smeared across the multiverse, with no way to know which instance of you is real. Because all of them are equally real, equally valid, equally convinced they are the original. Wormholes do not just connect places, they connect realities. They blur the boundaries between possible worlds. And if you traverse one, you do not know where you will end up. Not just in space, not just in time, but in which branch of the wave function, which version of history, which universe. This is the final implication, the ultimate consequence of wormholes being allowed by the mathematics. They do not just break distance and time, they break identity, continuity. The sense that you are a single coherent being moving forward through a single coherent timeline. You are not. You have never been. You are a pattern propagating through space-time. And space-time is multiply-connected, branching, looping back on itself, threading through dimensions you cannot perceive. And the pattern that is you is distributed across this structure in ways that cannot be visualized, cannot be mapped, cannot be understood without a complete theory of quantum gravity that we do not possess and may never possess. So where does this leave us? Sitting in a universe where the equations that describe gravity permit shortcuts through spacetime, shortcuts that violate causality, allow time travel, enable ontological weapons, and blur the boundaries between self and other, past and future, one universe and the next. Literally, your body comes apart at the atomic level, each particle drifting away, no longer bound to its neighbors. So you cannot defend against this. You cannot prevent someone from accessing the quantum wormholes that connect you to the rest of the universe. You can only hope that no one has developed a technology to exploit them. That no civilization, no intelligence, no process in the cosmos has figured out how to manipulate entanglement at scale. But if wormholes are everywhere, if they are the fundamental structure of quantum mechanics, then this technology is inevitable. Someone, somewhere, will discover it, and when they do, the concept of individual autonomy becomes obsolete. Because your quantum state is not private. It is accessible through the wormhole network. Anyone with the right tools can read it, alter it, control it. You become a puppet, not in a metaphorical sense. Literally, your thoughts are someone else's commands. Your actions are their decisions. And you would never know, because the manipulation happens at a level below consciousness. Below awareness, the part of you that asks, "Am I being controlled?" is itself subject to control. This is the darkest implication of wormhole physics. Not that they allow faster than light travel, not that they violate causality, but that they erase the boundary between self and other, between you and the universe, between autonomy and determinism. If wormholes are real, you are not separate. You have never been separate. You are a node in a network, connected to everything, influenced by everything, with no way to distinguish your own thoughts from patterns imposed through quantum channels you cannot see. And if this sounds like paranoia, consider this. In 2015, a team of physicists at Delft University of Technology in the Netherlands performed an experiment. They entangled two electrons, separated them by a distance of 1.3 kilometers, and measured their quantum states simultaneously. They confirmed that measuring one electron instantly affected the other. No signal traveled between them. No information was transmitted through normal space. The correlation was instantaneous. Einstein called this spooky action at a distance. He thought it proved quantum mechanics was incomplete. But the experiment confirms it. Entanglement is real, and if ER equals EPR is correct, that entanglement is a wormhole. A connection through space, possibly through higher dimensions, linking the two particles directly. Now scale this up. Your brain contains approximately 86 billion neurons. Each neuron contains trillions of atoms. Many of those atoms are entangled with atoms elsewhere in your body. And with atoms outside your body, particles you interacted with years ago that are now part of other objects, other people, scattered across the planet. You are connected to all of them through wormholes. Billions of microscopic threads linking you to the world, to the past, to particles that have traveled light years since you last touched them. And if someone can manipulate those threads, you are no longer in control. But this raises a question that physicists have been avoiding for decades. If wormholes are woven into the quantum fabric of reality, if they connect every particle to every other particle through a hidden network we cannot observe, then why does space appear continuous? Why do distances seem fixed? Why does light take 8 minutes to travel from the sun to Earth when a wormhole could bridge that gap instantly? The answer is scale. Quantum wormholes are Planck-sized, 10 to the power of -35 meters. At this scale, space-time is not smooth. It is foaming, fluctuating, a seething ocean of geometry that creates and destroys connections billions of times per second. These wormholes are too small and too unstable to transport anything larger than information. And even that transport is probabilistic, not deterministic. When two particles become entangled, a wormhole forms between them. But the wormhole does not stay open. It fluctuates. It collapses and reforms, vibrating at frequencies determined by the Planck time. 10 to the power of -43 seconds. At this scale, time itself becomes grainy. The smooth flow of seconds fractures into discrete ticks, like frames in a film. And between those ticks, the wormholes blink in and out of existence. This is why you cannot use quantum entanglement to send messages faster than light. The correlation between entangled particles is real, but it is random. You cannot control it. You cannot encode information in it. The wormhole is there, but it is too chaotic to use. Unless you stabilize it. Unless you pump enough negative energy into the throat to hold it open. To smooth out the quantum fluctuations. To transform a probabilistic connection into a deterministic one. Then the wormhole becomes traversable. Then it becomes usable. Then it becomes a tool. And this is what advanced civilizations would do, if they exist. If they have survived long enough to master quantum field manipulation, to generate negative energy at scale, to engineer space-time itself, they would not communicate using radio waves, which are slow and attenuate over distance. They would communicate through wormholes, quantum channels linking their worlds instantly, regardless of separation. This means the galaxy could be filled with civilizations, all talking to each other through a wormhole network we cannot detect. We are listening for radio signals, for optical pulses, for any electromagnetic signature that would indicate intelligence. But if advanced civilizations use wormholes, they produce no electromagnetic signature. Their communications are gravitational, encoded in the curvature of space-time itself, invisible to our telescopes, inaudible to our antennas. We are deaf to the conversation happening around us. Like insects crawling on the surface of a fiber optic cable, completely unaware of the terabytes of data flowing through it. The galaxy is alive with communication, and we are too primitive to perceive it. This is another solution to the Fermi paradox. Not that civilizations are rare, not that they destroy themselves, but that they transcend electromagnetic communication early in their development, switching to wormhole networks that are invisible to anyone who has not yet mastered space-time engineering. They are here, they are everywhere. We just cannot see them. But if this is true, if the galaxy is networked through wormholes, then Earth is not isolated. We are already connected. We just do not know how to access the network. We are like a computer with no network card, sitting next to a router, unaware that the internet exists. And if we are connected, if there are wormholes threading through our solar system, linking us to other stars, then we are being observed. Right now, someone, somewhere, might be looking at Earth through a wormhole mouth, watching our civilization, cataloging our development, waiting to see if we survive long enough to discover the network ourselves, or waiting to see if we destroy ourselves first. Because that is the pattern. That is what the data suggests. That is why the galaxy is silent in electromagnetic frequencies. Most civilizations do not make it. They develop technology faster than wisdom. They discover nuclear weapons before they develop stable governments. They achieve artificial intelligence before they understand consciousness. They manipulate genes before they comprehend ethics. And they die, not from external threats, from themselves, from technologies deployed without understanding the consequences, from feedback loops that amplify small mistakes into extinction-level events. Wormholes are another technology in this category. A discovery that grants godlike power without requiring godlike wisdom. Open the wrong wormhole, connect your world to a hostile environment, and your civilization ends in seconds. Not because the universe is malicious, because the universe is indifferent. It does not care if you survive. It does not reward caution or punish recklessness. It simply allows the equations to play out. And the equations allow wormholes. And wormholes allow disasters. This is why SETI, the search for extraterrestrial intelligence, has found nothing. Not because intelligence is rare. Because survival is rare. The window between discovering radio and discovering wormholes might only be a few centuries. And once you have wormholes, you either join the network or you destroy yourself trying. Most species choose the latter, not intentionally, through accident, through ignorance, through the arrogance of believing they can control forces they barely understand. And this brings us to a question that no one wants to ask. What if wormholes are already here? What if Earth is already connected to the network and we simply have not noticed? There are anomalies, phenomena that do not fit our models. The WOW signal, detected in 1977 by SETI researcher Jerry Eman. A radio signal, 72 seconds long, coming from the constellation Sagittarius, 30 times stronger than background noise. It has never repeated. No natural source has been identified. The signal matched the exact frequency we would expect from an extraterrestrial transmission, but it appeared once and vanished. What if the WOW signal was not a transmission? What if it was a wormhole opening? A brief connection between Earth and another star system, lasting only 72 seconds, just long enough for electromagnetic radiation from the other side to pour through. The radiation was not a message. It was leakage. Background noise from a civilization on the other side, spilling into our detectors before the wormhole collapsed. We interpreted it as a signal because we expected signals. But it was not communication, it was evidence. Evidence that the galaxy is networked. Evidence that wormholes open and close unpredictably. Evidence that we are surrounded by connections we do not understand. And there are other anomalies. The Pioneer anomaly. In the 1980s, NASA noticed that the Pioneer 10 and Pioneer 11 spacecraft were decelerating slightly, slowing down by a tiny amount that could not be explained by known forces. The deceleration was real, it was measurable, but it did not match any prediction. For decades, physicists proposed explanations. Radiation pressure, thermal recoil, gas leaking from the spacecraft. Sitting in a universe where the equations that describe gravity permit shortcuts through spacetime, shortcuts that violate causality, allow time travel, enable ontological weapons, and blur the boundaries between self and other, past and future, one universe and the next. We have not yet created a wormhole. We have not yet detected one. But the mathematics says they can exist. And in physics, what can exist does exist. The universe has had 13.8 billion years to generate every possible structure the equations allow, wormholes included. They are out there, invisible, silent, waiting, threading through the galaxy like capillaries through tissue, connecting regions of space we think are separated, collapsing distances we think are fixed, creating shortcuts we think are impossible. And one day, we will find one, or one will find us. A mouth will open near Earth, connecting us to some distant region of space, or some distant moment in time, and we will have seconds to decide whether to investigate or to run. And we will investigate. Because we are curious, because we are exploratory, because we cannot help ourselves. We will send probes, we will send signals. Eventually, we will send ourselves. And we will discover what lies on the other side. Perhaps it will be another galaxy. A shortcut to Andromeda, cutting 2.5 million years of travel time down to a single step. Perhaps it will be the past, a connection to Earth as it was thousands of years ago, before civilization, before agriculture, before language. Perhaps it will be another universe, a parallel branch where history unfolded differently, where humanity never evolved, where the Earth is a barren rock orbiting a dying star. Or perhaps it will be nothing, a void, a region of space so empty that the word empty loses meaning, and we will realize, too late, that we have stepped through a one-way door into a cosmic desert from which there is no return. This is what wormholes offer. Not certainty, not safety, not knowledge, just possibility. Raw, terrifying, boundless possibility. The chance to go anywhere, to access any time, to connect with anything, and no guarantee that the destination is survivable. The universe does not care whether you survive. It does not care whether you understand the structures it permits. It simply allows the equations to operate, and the equations allow wormholes, and wormholes allow you to destroy yourself in ways you never imagined. But they also allow you to transcend, to become something more than a single species confined to a single planet orbiting a single star in a single galaxy. If we survive the transition, if we master wormhole technology without annihilating ourselves, we join the network. We become part of the structure. We gain access to the galaxy, to other galaxies, to regions of space-time so distant that light from them will never reach Earth through normal space. We become a networked intelligence, distributed across the cosmos, connected through shortcuts that collapse the universe down to a comprehensible size. No longer isolated, no longer alone, part of a web of civilizations that have survived the same test we are facing now, or we become a cautionary tale. Another species that reached for the wormhole and fell through into oblivion. Another data point in the graveyard of intelligence that litters the galaxy, invisible, undetectable, known only to those who have already transcended and who watch the younger species with a mixture of hope and despair, wondering if this time will be different. We do not know which future awaits us. The equations do not predict outcomes. They only describe possibilities. And the possibility space includes both transcendence and extinction, woven together in the same mathematical framework that governs black holes, gravitational waves, and the expansion of the universe. Wormholes are real, not in the sense of being confirmed by observation, but in the sense of being permitted by the laws of physics, and what is permitted is, given enough time, inevitable. The shortcuts are coming. They might already be here. And when we find them, or when they find us, everything changes. Distance becomes negotiable. Time becomes reversible. Causality becomes optional. And humanity, standing on the threshold of a structure that should not exist, will have to decide whether to step through into the unknown or to remain confined to a universe where the speed of light is law and the stars are forever out of reach. The choice, if we ever have one, will define us. Not as explorers, not as conquerors, but as a species that either understood the risks and transcended them, or failed to comprehend the danger and was consumed by it. The wormholes do not care which path we choose. They are not moral structures. They are geometric features of space-time, indifferent to the consequences they impose on the matter and energy that passes through them. But you should care, because the universe you think you inhabit, the stable, predictable cosmos where distances are fixed and time flows forward and you are a singular, continuous entity, is built on assumptions that wormholes violate. And if wormholes exist, those assumptions are wrong. They have always been wrong. And the reality beneath them is stranger, more fluid, more terrifying than anything your evolutionary psychology prepared you to comprehend. So the next time you look up at the night sky, remember this. The stars you see are separated by distances measured in light years, but those distances might be illusions. Artifacts of traveling through normal space instead of taking the shortcut. The universe might be far smaller than it appears, far more connected, far more dangerous. And somewhere, hidden in the geometry of space-time, invisible to every instrument we possess, there might be a mouth, a threshold, a door that opens into something we are not ready for. It is waiting, silent, patient, inevitable. And one day, we will find it. If this exploration into the terrifying geometry of existence has left you questioning everything you thought you knew about space, time, and reality itself, then hit that like button and subscribe. Because the universe is full of structures that should not exist, phenomena that violate common sense, and truths that are more disturbing than any fiction. And we are going to explore every single one of them. The wormholes are out there, the shortcuts exist, and understanding them might be the key to our survival. Or our extinction. We have not yet created a wormhole. We have not yet detected one, but the mathematics says they can exist. And in physics, what can exist does exist. The universe has had 13.8 billion years to generate every possible structure the equations allow, wormholes included. They are out there, invisible, silent, waiting, threading through the galaxy like capillaries through tissue, connecting regions of space we think are separated, collapsing distances we think are fixed, creating shortcuts we think are impossible. And one day we will find one. Or one will find us. A mouth will open near Earth, connecting us to some distant region of space or some distant moment in time, and we will have seconds to decide whether to investigate or to run. And we will investigate. Because we are curious. Because we are exploratory. Because we cannot help ourselves. We will send probes. We will send signals. Eventually, we will send ourselves. And we will discover what lies on the other side. Perhaps it will be another galaxy. A shortcut to Andromeda, cutting 2.5 million years of travel time down to a single step. Perhaps it will be the past, a connection to Earth as it was thousands of years ago, before civilization, before agriculture, before language. Perhaps it will be another universe, a parallel branch where history unfolded differently, where humanity never evolved, where the Earth is a barren rock orbiting a dying star. Or perhaps it will be nothing, a void, a region of space so empty that the word empty loses meaning, and we will realize too late that we have stepped through a one-way door into a cosmic desert from which there is no return. This is what wormholes offer. Not certainty, not safety, not knowledge, just possibility. Raw, terrifying, boundless possibility. The chance to go anywhere, to access any time, to connect with anything. And no guarantee that the destination is survivable. The universe does not care whether you survive. It does not care whether you understand the structures it permits. It simply allows the equations to operate. And the equations allow wormholes. And wormholes allow you to destroy yourself in ways you never imagined. But they also allow you to transcend, to become something more than a single species confined to a single planet orbiting a single star in a single galaxy. If we survive the transition, if we master wormhole technology without annihilating ourselves, we join the network. We become part of the structure. We gain access to the galaxy, to other galaxies. Two regions of space-time so distant that light from them will never reach Earth through normal space. We become a networked intelligence, distributed across the cosmos, connected through shortcuts that collapse the universe down to a comprehensible size. No longer isolated, no longer alone, part of a web of civilizations that have survived the same test we are facing now. Or we become a cautionary tale. Another species that reached for the wormhole and fell through into oblivion. Another data point in the graveyard of intelligence that litters the galaxy, invisible, undetectable, known only to those who have already transcended and who watch the younger species with a mixture of hope and despair, wondering if this time will be different. We do not know which future awaits us. The equations do not predict outcomes. They only describe possibilities. And the possibility space includes both transcendence and extinction, woven together in the same mathematical framework that governs black holes, gravitational waves, and the expansion of the universe. Wormholes are real. not in the sense of being confirmed by observation, but in the sense of being permitted by the laws of physics. And what is permitted is, given enough time, inevitable. The shortcuts are coming, they might already be here, and when we find them or when they find us, everything changes. Distance becomes negotiable, time becomes reversible, causality becomes optional. And humanity, standing on the threshold of a structure that should not exist, will have to decide whether to step through into the unknown or to remain confined to a universe where the speed of light is a law and the stars are forever out of reach. The choice, if we ever have one, will define us. Not as explorers, not as conquerors, but as a species that either understood the risks and transcended them, or failed to comprehend the danger and was consumed by it. The wormholes do not care which path we choose. They are not moral structures. They are geometric features of spacetime, indifferent to the consequences they impose on the matter and energy that passes through them. But you should care, because the universe you think you inhabit, the stable, predictable cosmos where distances are fixed and time flows forward and you are a singular, continuous entity, is built on assumptions that wormholes violate. And if wormholes exist, those assumptions are wrong. They have always been wrong. And the reality beneath them is stranger, more fluid, more terrifying than anything your evolutionary psychology prepared you to comprehend. So the next time you look up at the night sky, remember this: the stars you see are separated by distances measured in light years. But those distances might be illusions. Artifacts of traveling through normal space instead of taking the shortcut. The universe might be far smaller than it appears, far more connected, far more dangerous. And somewhere, hidden in the geometry of spacetime, invisible to every instrument we possess, there might be a mouth, a threshold, a door that opens into something we are not ready for. It is waiting, silent, patient, inevitable, and one day we will find it. If this exploration into the terrifying geometry of existence has left you questioning everything you thought you knew about space, time, and reality itself, then hit that like button and subscribe. Because the universe is full of structures that should not exist, phenomena that violate common sense, and truths that are more disturbing than any fiction. And we are going to explore every single one of them. The wormholes are out there. The shortcuts exist. And understanding them might be the key to our survival, or our extinction.